This is my 8-ball pinball table. It was manufactured in September of 1977 and I got it in 1998. At the time, I thought that a 21-year-old pinball table was crazy old. Now, in July of 2020, it's 42 years old. When I got the machine, it didn't work. The lights went on, but that's about all I recall. I didn't have a manual, and Google was just an infant of a company that I was most certainly not aware of. I'm sure an old search engine like Hotbot, Excite, Web Crawler, Ask Jeeves, Yahoo, Dogpile, AltaVista, Lycos, InfoSeek, Metacrawler would have turned something up for me, but the thought of repairing a pinball table was complicated and scary. Just look at all these things. So I had somebody over to the house to repair it. The MPU had a battery that leaked all over the place. The person I had over took all three of these boards and replaced with these. The MPU is a -35, which is a direct replacement for the original board. As far as I know, the -35 board was a kit that one could buy and put together. But that company is long since gone. There have clearly been multiple printings of this board. For example, my board has www.2bit.com printed on it, which sadly is now a Bitcoin exchange website. This would have been a great URL to keep in the arcade or pinball scene. Another -35 PCB I found while researching has the URL www.2bits.com printed on it. That URL redirects to GameboardUSA.com, and guess what? They sell the -35 board. The phone number also goes to the same company. Now, I had let poor 8-ball go into a bit of disrepair over the past few years. From time to time, I would turn it on and the playfield worked, but the lights would flicker and half the chimes wouldn't work. I figured that this was all because of loose connections, but I could never seem to find the time to work on it. However, earlier this year there was this thing that happened. It caused most of us to stay inside, which, to be honest, I was okay with. So this was the perfect opportunity to work on the machine. The first thing I did was an inspection. Very quickly I noticed this on my Solenoid driver board. This thing that looks like a transistor is actually a silicon-controlled rectifier, and it was blown apart at some point. I think I know when, but we'll talk about that a little later. Also, this capacitor and resistor are black. I also took a look at the chimes and found that this solenoid was black. I'm no electrician, and I can barely use a digital multimeter, but I figured that maybe the solenoid fried, which blew the circuit. However, I was not quite right in my diagnosis of what happened and which parts were involved with which failure. Next up, I inspected the lamp driver board, and again, very quickly I noticed that these little rectifiers were rotted and falling apart. This was not terribly surprising, as the battery on the -35 board just above it appears to have sprung a leak. I'll need to clean up the battery alkaline and figure out a replacement. So my first plan was to repair all three boards and replace the black solenoid for the chimes. I set out to figure out what all of these parts were and where I could get them from. Outside of the solenoids, this stuff is pretty cheap, so I made sure I had enough extra to make some mistakes. It's at this point, before getting into the repair work, that I should explain how I went from being scared of the insides of a pinball machine to diving headlong into repairing lamp and solenoid circuits. I knew that I had a Plan B. Plan B were these Altec boards. While not inexpensive, replacing one of the three boards with one of these was not outside of my budget. I figured that the MPU and its battery was an easy fix and wouldn't need to be replaced. But the lamp and solenoid driver boards were questionable to me. The lamp board seemed to be the easiest to work on, but had the most fixes to do, whereas the solenoid board seemed to be the more complicated, but had less things to fix. If I could fix the MPU and one of the other two boards, I'd be perfectly happy to buy an Altec replacement board for what I couldn't fix. The first thing I'm going to do is get rid of this battery. As far as I know, the battery saves high scores, and that's it. You can run the machine perfectly fine without it, but I'm going to remove it, clean up the site, and then install this 5101 NVRAM adapter. This will do the job of the battery and eliminate the risk of leaking alkaline. There are a number of ways to handle the alkaline cleanup, and I recommend doing some research to find a method that you are most comfortable with. First, I removed the old battery. Then I soaked the area with vinegar for 15 minutes. After that, I added baking soda and scrubbed the area. To rinse the area off, I used distilled water. Then I used a heat gun on low to dry out the area. Finally, I installed the 5101 NVRAM adapter. For my game and many other Bally games, this is a drop-in procedure. For Stern, Williams, and Gottlieb, you'll need to do a little bit more. Next up is replacing the rectifier on the lamp board. You can see that Q56 and Q57 need some attention. So do Q18, Q11, and Q4. This would appear to be the path that some of the alkaline dripped. You can do some additional testing with a digital multimeter, and while I have no idea what the numbers should be, you can test for shorts and compare numbers from rectifier to rectifier. If there is a wild deviation between one rectifier and another, you might want to make a note of it and during a lamp test see if that lamp is on, off, or flickers. Now I will remove the bad parts and solder in some replacements. A quick disclaimer here is that I'm not great at soldering, so please don't use any of this as a lesson in how to solder. For that, check out Voltar's channel. So Q57, Q56, Q18, Q11, and Q4 are all replaced. Now on to the solenoid driver board. So my plan is to replace the resistor, the rectifier, and the two capacitors that are on either side. Here is the circuit and the adjacent capacitor, and here is our graveyard of parts. Okay, time to put this thing back together and see if it's fixed. Here goes nothing. Watch the LED. We're looking for 7 flashes to ensure that the MPU goes through its internal diagnostics. Okay, well, that didn't work. It's the same circuit. The resistor and capacitors look okay. Well, while I think about how to fix this, I might as well tackle this power plug. I don't know, maybe if the table was grounded, the circuit wouldn't have blown in the first place? All of these machines that I have received over the years had the ground pin ripped out of the plug. I assume that they were all at bars or bowling alleys in the 80s. Were there no 3-prong outlets back then? With that done, I'll take a look at these chimes. I figured I would need to replace that one black solenoid, and probably should have done that alongside the circuit repair. What you can see here is that 2 of these pins inside the solenoids are stuck in the up position. This isn't something I noticed when this footage was shot. It wasn't until later when I took everything apart did I finally notice this. So now I'll test the diode on the solenoid. Again, I should have done this at the same time that I was reviewing the parts I'd need for the lamp and solenoid board. I don't know what numbers to look for, but these 2 that are generating tone mean that the connection is shorted or always on. I only have the one replacement solenoid, so I'll replace that black nasty one I found earlier. I'll reclaim this little pin inside the solenoid sleeve. This is what strikes the chimes. As I took it out, I noticed that the sleeve for the original is stuck. It probably got so hot being always on that it melted the plastic. I took 2 others out to inspect and see that the insides of each are bulging. On one I can't get the pin to go through, and the other one has a little bit of resistance. After replacing the rectifier on the board, I traced my wires and discovered that the circuit I was working on was for the 1000 chime, but the solenoid I replaced was for the 100 chime. You can hear now that I have one more chime. Now I know that I need 2 more solenoids, so while I wait for those to arrive, I'll fix this credit button. It's long since fallen apart. It's held together with electrical tape. I solder these together and use heat shrink tubing instead of electrical tape to prevent future shorts. So my new solenoids have arrived and I've installed them. You can see that these have 3 solder legs rather than 2 like my old ones. All of the online pinball shops seem to have run out of CJ31 2000 solenoids, so after a bunch of research and impatience, I bought these. From what I read, the 31 and 2000 are important, and the interior bobbin size for the sleeve. I couldn't find any information about bobbin size, so I just rolled the dice and got these. On test number 1, it fired and stayed on. I tried it a few times to see if I could figure out what was happening. I installed the extra chime as well, and it did the same thing. At this point I was a little baffled. I thought it might be because of the 3-legged solenoids I had bought. But after some more research, I found that you can attach the multimeter to ground and touch the positive to the metal piece on the rectifier to get a reading. Any reading of 0 means the rectifier is shorted and needs to be replaced. Well, I found 2 that were shorted, and lo and behold, they were for the ones that were stuck on. So I replaced those, and after testing them out, I turned the pinball machine on, counted to 7, and... ah, glorious chimes. And check out this new credit button. Next, I wanted to replace this nasty skirt. Repairing a pop bumper has always seemed like a daunting affair, but it turned out not being that difficult. The worst part was the light socket. Look how nice that looks. If I could find replacement 8-ball tops, I would buy them, as these are pretty yellow. Okay, let's put this all back together and clean up my tools. In hindsight, I could have handled this job quicker and with less shipping charges if I would have first taken notice that only 1 chime worked and inspected the 3 solenoids for the chimes that weren't working. Then I should have mapped out the circuits on the solenoid board to the chimes. This would have revealed the bulges inside and the stuck pins and shown me exactly what needed replacing. It would have also uncovered that the black solenoid and blown out circuit weren't the same. I would have likely ended up in the same place where 2 of the chimes would fire and stay on. It was luck that I stumbled across someone's pinball troubleshooting site that had the ground to metal tip advice. So, as it goes, I could have saved some time and money if I would have done just a little bit more legwork. Well, in summary, somewhere along the line my 100, 1000, and extra chime solenoid shorted, either at the circuit, or at the diode, or on the solenoid. The 1000 circuit literally exploded while the other 2 got so hot that they were black and they had melted the interior plastic. Why? Missing ground pin on the power plug? Old parts? Solar flares? I have no idea. As for when the 1000 chime solenoid originally blew, check out this clip from a podcast I used to do from June of 2008.
If you could ultimately change your own all right, no, wait, here's a thought. Okay, so if you think about those suicide bombers that are like, you know, I'm martyring my cause, I'm gonna blow myself up. What the
hell was that? We used to record the podcast right next to 8-ball. It was turned off. but it sounds a lot like the pop of the replaced circuit, right?